Welcome to video 3. This is Manivan, and I'll be teaching you organic chemistry. Today, we will be dealing with the oxidation of two alcohols. For each molecule, we will draw its structure, classify if it is a primary, secondary, or tertiary alcohol, oxidize the alcohol, and name the product or products if there are any. Here we go. The first alcohol has the name 4-methyl-2-heptanol. Like always, we need to work backwards in order to draw the structure. The prefix hept in heptanol tells that we have 7 carbons in the longest carbon chain. Let's count the carbons. 1, 2, 3, 4, 5, 6, 7, and connect the lines. The suffix OL indicates that we have an alcohol in the structure, and the number 2 tells us the location of the alcohol. Find the second carbon and draw in the alcohol. Alcohol is indicated with abbreviations OH for the bond between oxygen and hydrogen. Now, methyl tells us that we have a 1-carbon substituent group, and the number 4 indicates that the methyl group is at the 4th carbon. Draw in the first carbon and connect the line. Here is the drawing for the alcohol, 4-methyl-2-heptanol. To classify the alcohol, let's bring back the drawing that we just finished. First, we need to locate the alpha carbon. Remember that this is the carbon that is directly connected to the OH group, so the alpha carbon is here. There are 2 bonds leading directly from the alpha carbon, one on the left and one on the right. These 2 bonds lead to the beta carbons. Since there are 1, 2 beta carbons, this states that we have a secondary alcohol. To determine if we can oxidize the alcohol, we will begin with the drawing. Recall that when a secondary alcohol is oxidized, we should get a ketone. So again, let's identify the alpha carbon. From there, we have 1, 2, 3 bonds to the alpha carbon. So that means we can only have 1 alpha hydrogen to complete the 4 bonds that a carbon needs. Remember that we will need an alpha hydrogen in order to oxidize the alcohol. Since there is only 1 alpha hydrogen, that means we can oxidize the alcohol only 1 time. We will use the alpha hydrogen to oxidize the alcohol, and that will consequently give us another bond here. Therefore, this hydrogen must go, since oxygen can only have 2 bonds. When this elimination occurs, we must also remove the alpha hydrogen in order to fulfill the 4 bonds that the alpha carbon requires. So when we completely oxidize this alcohol, we should get an exact copy except for the addition of the double bond and the removal of hydrogen in the alcohol as our product. Since all alpha hydrogens are used up in the reaction, there is no more oxidation reaction. Now let's name our final product from the oxidation reaction. Yet again, we will start backwards in naming the product. First, we need to count up the number of carbons in the longest carbon chain. We have 1, 2, 3, 4, 5, 6, 7 carbons, so that means we have a heptane. Notice that we have a polar group with a carbon double bond to oxygen in the middle of the chain. This means that we have a ketone. Now we just drop the last letter E in heptane and take the suffix ONE from ketone to give us heptanone. Since the location of the ketone group is at the 2nd carbon, we write the number 2 in front and use a hyphen to separate numbers from words. There is a methyl group at the 4th carbon, so we write methyl with the number 4 in front. The name for the final product is 4-methyl-2-heptanol. The second alcohol has the name 5-sec-butyl-2-decanol. To draw this alcohol, again, let's look at the last part of the name. The prefix dex indicates that we have 10 carbons in our longest chain. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and connect the dots. The suffix OL articulates that we have an alcohol, and the number 2 indicates its location. There it is. Now, butyl informs that there is a 4-carbon substituent group, and sec tells that it is attached at the second carbon to the main chain. The number 5 directs that this group is located at the 5th carbon. Draw the 4 carbons and connect the lines. Alright, here's the final drawing. Let's redraw the drawing to classify the alcohol. Once more, find the alpha carbon, which is directly connected to the alcohol group, and count the number of bonds that are connected to the alpha carbon. We have 2 bonds leading to the beta carbons. In all, we have 2 beta carbons, so that means we have another secondary alcohol. One more time, we will use the drawing to oxidize this alcohol. As before, a secondary alcohol will oxidize to get a ketone. Yet again, let's find the alpha carbon and count the number of bonds attached to it. We have 1, 2, 3 bonds, so there is only room for 1 alpha hydrogen. The presence of the alpha hydrogen will allow one oxidation reaction of this alcohol, and thus adding another bond here. When doing so, we will eliminate this hydrogen and the alpha hydrogen to satisfy the 4 bonding that the alpha carbon desires. So when we oxidize the alcohol, this becomes our product. The product is an identical copy of the alcohol with the addition of a double bond and the removal of the hydrogen in the alcohol group. Since all alpha hydrogens are used up in the reaction, the oxidation reaction is complete. Let's begin with the final product drawing from our oxidation reaction to name the product. Like before, we will work backwards in naming and start by counting the carbons in our longest chain. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which means we have a decane. Here, we have a carbon double bonded to oxygen in the middle of the chain, which gives us a ketone. Similar to our first molecule, we will drop the letter E in decane and steal the suffix O and E from the word ketone to build the word decanone as our root name. Since the ketone group is at the second carbon, we will attach the number 2 in front with the hyphens to differentiate numbers from letters. Next, notice that we have another substituent group with 4 carbons attached to the main carbon at the second carbon in this group. So this gives us sec-butyl. Since its location is at the 5th carbon, we add the number 5 in front. In all, the complete name of the final product is 5-sec-butyl 2-decanone. That's it for today. Thank you for watching.